Okay. All right. Well, it's week 9 and it's Thanksgiving week. So I just want to say a few things about our schedule this week. Okay, well, you guys are here today, lecture. Let me magnify this a little bit. Well, I will have office hours at 11:30. That's normal. Tomorrow, I will have online office hours from 10 to noon. Wednesday, there will be no class. Instead of class, I will have office hours from 9 a.m. to 11. I'll take a break at 11, and then I'll have office hours at 11:30 to 12:30. Okay, so no class. We're not going to meet here. I guess today is our last lecture then, and that's that. Okay, Thursday is Thanksgiving, so no office hours, no class. Friday, no class. I will have office hours online at 11:30, and then on Saturday, no office hours that day. Okay, and then week 10, that's when final projects start being done. Okay, final group presentations. So there's no lecture. Basically, no lecture Monday or Wednesday of week 10. And then on Friday, a few groups will be presenting on Friday. So this is what we have. So on Monday, no lecture. I will have office hours from 11:30 to 12:30, so that's really like last minute. If you guys have some question, okay. But I'm not going to have office hours on Tuesdays or Thursdays because I've got group projects pretty much. Scheduled. So final group projects, you guys should know when your group projects are scheduled. So anyway, final group projects is scheduled week 10, Tuesday, no office hours and just final group projects. And then on Wednesday, again, no lecture, but I will have office hours from 11:30 to 12:30. And then Thursday, no office hours, but final group projects. And then week 10 Friday, for groups that have signed up and anybody who wants to see other group presentations, we will have some class presentations. And I will have, I guess, some office hours, and we'll have group projects as scheduled. Oh, maybe I'm going to scratch these office hours. Let me just double check. I might end up scratching these office hours. Okay, and then week 11, which is finals week. No class, no office hours. Some groups do have final projects, and that's that. Okay. So yeah, today would be, I guess, our last lecture of the quarter in the year of 2022. I guess. But I will see. I should see everybody during their final group projects. Okay. Any questions about that? No, we're good. Okay. And then, as far as today's lecture goes, here, let me open this up. I wanted to go over kind of an example of an analysis that went wrong, like another kind of group project that another student group did in the past, where they messed things up, okay, and it's not unreasonable for something like this to happen. What is unreasonable is that nobody caught it and nobody thought they should fix it, and they ended up kind of copying this type of graph that they made, and they did it for a bunch of different things. But so they lost a lot of points. Okay, so here we're going to take a look at an analysis that went wrong, and I want to kind of discuss what went wrong, tips to avoid it, what could have been done to correct it. So yeah, the following slides are based on an actual group report, and the group made some kind of critical mistakes in their analysis, and unfortunately, yeah, nobody caught it before they presented. And yeah, So the data, I think, is actually from 2014 to 2018 or something, 2017. So the group, they found some NBA data, okay? And I know I've been doing a lot of kind of NBA examples, but this could apply to really any kind of scenario where you might be wanting to do some kind of summarizing. So this group, their data had kind of individual game logs. So it was like team 1 was Atlanta, and team 2 was Toronto, and then and the Atlanta got 102, and then their opponent was 109, and they lost. Okay, so Atlanta, it was an away game for Atlanta. They went to Toronto and they lost, and there's a whole bunch of different variables and stuff, and you can see the original data set has 9,840 rows, 9,840 rows, 41 columns, right? And so it's a decently big data set because it keeps like every single game that was kind of played. And so there are 82 games per team per season. So there are 30 teams, so you do 30 times 82. I don't know what that is. 30 teams times 82, 2,460, and let's multiply that by 3. What, 2,460 times 4? Yeah, so 4 seasons, okay? So 82 times 30 teams, 82 games, 4 seasons, for a total of 9,840 rows, okay? So that's kind of where this group started off with. They were looking over at 4 seasons of data, and they wanted to kind of see like what is related to wins and losses. It's a reasonable question, okay? And so I don't know, do you guys see anything wrong with this line of code where they just kind of took this original data and then they selected a bunch of columns such as, win or loss, team, date, team points, field goals attempted, and anything like that. They just selected a bunch of these columns. Is there anything wrong here? And no, nothing's wrong with this statement, okay? Right here, they're just selecting columns. Nothing's wrong with it. And if you kind of just take a look, yeah, we've got, different whatever you call it, stats, and then, whether the team won or lost, and the team name, and, the date that the game was played, and, a bunch of these columns, okay? How many field goals were attempted during that game, how many field goals were made, okay? So they, attempted, this was one game where Atlanta attempted 80 shots and they made 40 of them. And so their, shooting percentage is 50% there, okay? Field goal percentage there. So that's this data. That's fine. Nothing is wrong there, okay? Okay, what about this line? So here they decided to create 2 columns here. One is wins or losses, and wins, and currently the win or loss column is an L or a W, and they're turning this into basically a true or a false. Win or loss equals W will turn win or loss into true or false. So if it's a win, it's going to be true, and if it's a loss, it's going to be false. Percent threes is 3-point shots attempted divided by field goals attempted. Okay, so this is like what percentage of their shots were that they attempted were 3-pointers, right? So, we're half of their. So this is, a question on like what percentage of shots were 3-pointers, and this calculation is fine. That would add, another 2 additional columns here. Okay, what about this? Group by team, and then summarize win percentage. Now that win or losses is true or false, you can take the mean of true and false, and you'll get a proportion. Okay, so win percentage, they're going to get the proportion multiplied by 100, and then they're going to select assists, total rebounds, so on and so forth. Okay, And it says summarize has been grouped by teams. Okay, do you see anything wrong here? Maybe, maybe not. Well, based on this code, how many rows would you expect the resulting table to have?
30.
Okay. It's a reasonable expectation is to expect that there would be 30 rows because there are 30 teams in the NBA. So if we're grouping by teams, we expect to see 1 row per team, and so we would expect to see 30 rows. Okay, so so this is very important. Okay, and this is, I think, what the group failed to do is whenever you write a code, you should have something in your brain. What do I expect my code to look like? What output should I expect, right? So that's a reasonable thing. And then you look at the output and you ask, does my output match what I expected? And if it does, then that's a good sign. And if it doesn't, then you should go back and look at what your code did. So based on this, we're grouping by team and we're summarizing, and we want to get the mean wins, okay, mean percentage. And we're expecting 30 rows. When we look at it, how many rows do we have? We still have 9,840, okay? And it says I have groups, team, 30. It says I do have 30 teams. Do we see what went wrong? Why do I still have 9,840 rows? So did it calculate the winning percentage? It did, and it wrote 53.4, and then wrote 53.4 like everywhere. Look at this column assists. What's going on here? I get 26, 26, 26, 28, 18, 20, 23, 33. What happened there? Yeah.
Is it because there's different values for all the other columns, so it can't group it by?
Yeah, so the thing that happened was it just basically copied. Like I don't have the assists column here, but basically it just copied a bunch of these kind of values, okay? So rather than it calculated win percentage, but then it just kind of copied the column for assists, okay? And so yeah, as you write these things, and if you have a summarize thing, and I'm sure all of you will be using summarize statements in your code, you want to end up with fewer rows, right? Anytime you're using summarize, you want to start off with a bunch of rows, and then you want to kind of compress it down to fewer rows, right? Like you basically 1 row per group. So you have some kind of grouping variable, and you want like 1 row per group. And so we were expecting like 30 rows, okay? And if you look at this code again, what's happening is anytime you do a summary function, or a summarize, each of these things should have summary functions. Summary functions are functions that take multiple values and turn them into one value, okay? So mean is a summary function. You give it 10 numbers and you say, what's the mean of 10 numbers? And the mean is 1 number, right? What are other examples of summary functions? Things like the sum, okay? Give me the sum of 10 numbers, you get 1 number. Standard deviation, summary function. I give you 10 numbers, the standard deviation of 10 numbers is 1 number, okay? Or even things like what is the minimum? All right, if I give you 100 numbers and ask for the minimum, it's just 1 value, or the maximum is just 1 value. So those would all count as summary functions. They're going to just return 1. Okay. Assists is not a summary function, and so what it's going to do is it's going to take the entire column of assists, perform no operation on it, and just return the entire column of assists. Okay, and that's what's going on. And they just kind of put in the variable names, and so it just kind of ends up returning that entire column what they need to have done is they needed to have wrapped assists with summary functions like mean or sum or median or whatever, right? All of these variable names needed to be inside a summary function, okay? Otherwise there's no summary being done, okay? And that's why we're getting still 9,840 rows, right? And so I deducted points very heavily on this team for like not catching this kind of mistake, basically not checking their work along the way as they're working to kind of make sure that, you know, the things are going as they would have expected, okay? So this is the plot that they ended up producing as a result of their kind of mistake, okay? Before I go on, let me go ahead and give you your first view quiz answer for today. I guess our last view quiz ever. Okay, the letter D is your first view quiz answer. D as in dog. D as in dog is our first view quiz answer for today. Okay, and so this is the resulting graph. Okay, and this is I think they wanted to show the relationship between assists and win percentage. And what do we end up seeing here? What's going on here? Can anyone interpret what's happening in this graphic? Yeah, well, it's a bit of a mess, okay? And let me just point out what's going on. Okay, well, what does each dot represent? Do we know what a dot represents? How many dots are technically being displayed here? We're using this data, NBA Compare. So how many dots are technically in this graphic?
I think like 9,000.
9,840, okay? So each row in this data set is going to become a dot, all right? And what's happening is it doesn't look like there's about 10,000 dots because there's a lot of kind of stacking. A lot of dots are plotted in the exact same position, okay? And what is this? I got a whole bunch of dots in a row. What's going on there? So they did X as assists and Y as win percentage. And what we're basically doing is we're plotting assists against win percentage. And so all this Atlanta team, their win percentage is 53.4. And they have what, 4 seasons times 82 games. So what, that's 388 games or something like that, 328 games, okay? So in this row at 53.4, so 53.4 is something like, I don't know, one of these rows here, 53.4. There's technically 328 dots, and there's a dot that corresponds to 26, 53.4. There's another dot stacked on at 26, 53.4, and another dot at 26, 53.4, and a dot at 28, 53.4. And that's, you know, they're all just kind of in a line. And so, you know, what we're seeing is we see also the dots are also in columns, and that's because there's games where there were 20 assists, games where there are 21 assists, 22 assists, 23 assists, 24 assists, and we're just seeing kind of like we can't see like the density of points and things like that, and the fact that they're all in horizontal bands. If you see horizontal bands in your data, you got to ask yourself, why am I seeing horizontal bands? And does it make sense that I'm seeing horizontal bands, okay? So if there's a reason why you would see a horizontal band, okay, kind of like, I think early on in one of our homeworks, you did like storm, like hurricane data or something, and I asked you like, why are there horizontal bands, okay? And the reason for that was like, well, they were just rounding the wind speed to the nearest 5 miles per hour or something. And that's a reasonable explanation, right? Because like, how do you measure the wind speed of a hurricane? And it's hard without putting yourself in great danger, right? So you're only gonna like get some approximate reading. right? So it doesn't make sense to report that the wind speed is 112.775 miles per hour, because that might, and then, if you think about like with a hurricane, it's not like all the wind speed is exactly the same everywhere. So, you just say, all right, we areas reported gusts of, or like wind speeds of this thing, and, we just kind of go with the nearest 5 miles per hour. That kind of makes sense, okay? That kind of thing. And if you're like, okay, this is why I'm seeing horizontal bands, I'm not seeing anything at, 71.6 or 72.3 or whatever, for this reason, that makes sense, okay? And if you ask, okay, why am I seeing wind percentage kind of like this? Well, you say, okay, well, what should be going on? And if it's one, if we're seeing, 30 different wind percentages, then maybe I should only have 30 different dots or something. So I just kind of wrote, dots of horizontal lines appear. Each horizontal line is basically a team, and each dot's an individual game. Dots are evenly spaced out because there were games where teams had 18, 19, 20, again, same if you have like vertical things. And, if you have if one of your variables is numeric and discrete, you're probably going to see, vertical bands and stuff like that, okay? And so, and they add a trend line, and this trend line basically is kind of worthless, all right? There's like a upward curve, and they were like, based on the upward curve, there's more assists means higher win percentage. But, I think this trend line was just kind of influenced by up here. These were the Warriors with a, very high win percentage during that kind of span of time. And they also had a high number of assists, and maybe that was part of their winning strategy, but also just, here are teams, I don't know. So anyway, and they had similar graphics for other stats, not just assists, but they also did it for like rebounds and different kinds of things. And nobody kind of thought to question like, what, why do we have horizontal bands? Why are there still 9,840 rows or things like that? Okay. Here's a different graphic that they also kind of produced, and this is the command they did. They said, y is wins being a true or false if they won versus if they lost, and x is the number of assists. And here they added jitter, so you don't get vertical banding, so it kind of spreads out the vertical band. You can still see a little bit of vertical banding, but it's jittered. So you do see some of the density, right? So back here, you didn't see any density. You couldn't tell like which of these bands had a ton of dots and which ones didn't. And here you can see, okay, all of these ones, there's tons of dots, and then out here there's fewer dots, and out here there's fewer dots. So credit there, okay, credit there. And then also same with, they added jitter in terms of like true, so it kind of spreads it out rather than having just one line at true and one line at false, okay? But I would still argue that, and I think the point of this graphic here was that, they said, okay, well, there's a shift, the center for the assists where they won is higher than the center of the assists for when they lost, okay? So, there's kind of a difference there, and that's a reasonable statement to make. I personally think this is not the best graphic to do kind of that. It's a reasonable statement, and certainly a graphic could be used, but I would just say, you know what, just do a box plot. A box plot is so much simpler and to the point regarding like the difference between games that were won, how many assists there were, and games that were lost, how many assists there were. And you can see, oh yeah, there's a shift in the median. There's a shift in Q1 and Q3. And we also see that like 50% of games, okay, have between for winning teams had between 21 and like 27 assists. So kind of a fairly tight band of, assist numbers. And then for games that were lost, it's between like 18 and 24, okay? So, and that's the 25th and 75th percentile. So a pretty tight range here. And then, games that have, fewer than 10 assists total is pretty much an outlier, okay? Especially, and then if you're going to win, having fewer than 10 or 11 assists is an outlier. And then, anytime you're having more than 35 assists, that's also considered an outlier, right? I think the box plot, in my opinion, the box plot does a far superior job of kind of summarizing the data than this. Here, this just gives you a sense that, oh yeah, there were a lot of data, a lot of points in my data, 9,840, and we get a kind of sense that, oh yeah, there might be around 10,000 points in this thing. But I think a box plot would have been far superior there. Okay, so that's a potential fix. Basically communicating the same thing, but actually, in my opinion, communicating more, because with a box plot, you get to see what actual value is the median, what actual value is the Q1 and Q3 and things like that. So, that's fine. I was more critical of this. So I wanted to say, well, could I have gone back and fixed that issue? And so here I corrected it by changing the line. So I took basically the same line, and here I just did for one of the columns, assists, and I could have done basically the same thing here. I calculated average assists by doing mean of assists. Okay, so remember the issue back here was they needed to wrap these variables with a summary function like the mean or sum or something like that. Okay, so total rebounds, they should have done mean of total rebounds, mean of offensive rebounds, mean of steals, mean of blocks, mean of 3 points attempted, mean of turnovers, mean of total fouls. And here I'm just doing mean of assists, just to do this, okay? And then also, another thing I wanted to do was I wanted to, rather than just do each team, because to me, it does not make sense to summarize teams across multiple seasons, okay? So, in sports, during the season, your roster, there's going to be some changes. You're going to have some trades happening. Players switch teams in the middle of the season. That does happen. But a lot of times the roster is fairly consistent throughout an entire season. However, a lot of players do switch teams between seasons. So that's a very common change for players to switch teams between seasons. And so for example, in Los Angeles, there's the Lakers. And to just average all the Lakers against across multiple seasons is I don't think makes sense. So taking that 9,840 rows and turning it just down into 30 groups with just 30 teams did not make sense to me. To me, I think we should have made 120 groups because there are 30 teams and there were 4 seasons. So we would have the 2015 Lakers and the 2016 Lakers and the 2017 Lakers. So basically one dot per team per season. And so I wanted to do a group by team and season. So this is going to end up creating 120 rows. Okay, 120 rows, which will be grouped by team and season. Okay, so after I do that. This did require a little bit of, just a little like trickery or cheating. Okay, if you look at the original data, there was actually no column for what season the game took place in. So all I have is the date. And so LubriDate has a function where it just says, oh, okay, what was the year? Okay, and if I ran what's the year, it would have said 2014. The only problem here is that if I did this, the games that took place in one season, some of the games will take, season starts in October and ends in like April. Okay, the regular season starts in October, ends in April, and so the data would have shown something like, the years 2014 and the years 2015 for the same season. So to kind of just get everything into the same year, what I did was I just said, let's add 6 months. Let's add 180 days. And so that's going to just end up pushing the October dates somewhere into 2015. The April dates get pushed forward, but they also stay in 2015. And so I just say, hey, add 6 months and then tell me what year you are in 6 months. And then that's just going to be kind of a, tell us like what season it took place in. So, games that took place in 2014, 2015 will show up as the 2015 season. And games that took place in 2015 and 2016 from October 2015 to April 2016 will just get shown up as the 2016 season. Does that kind of make sense, what I did here, right? So, I mean, I could have, sometimes, so students, sometimes the solution is a lot simpler than like what it needs, like what first comes to mind, right? The first thing that came to my mind was like, oh, some games are like 2014 and some games took place in up through April 2015. And so my initial thing was like, okay, if it took place after October, then add a 1, and if it took place before, May, then leave it, and then I would have needed some kind of if-else statement, and I just and I could have written that, but to me it was just like, oh, let's just add a few days, so anything that was in October ends up in the following year. Okay, so that's and then I had kind of a large buffer because there's a large period of time where no regular season games are played, so I didn't need to actually figure out the exact number of days to add to make sure I'm gonna end up in the other year. Okay, so anyway, that's what we have, and then so now that I've done that, okay, so again, anytime you do a summary operation, and I ended up creating the plot, we just ask, okay, what is how many rows do I have? Now I have 120 rows. 120 rows. How many columns? I have the team, I have the season, the win percentage, the number of assists, and this kind of makes sense to me. All right, 120 rows. That's reasonable. And so now I plotted this, and now we can see, I think this shows a little bit of a better idea of what's the relationship between assists and win percentage. And the relationship isn't like super strong, but we definitely see positive correlation, right? More assists on average, higher win percentage, fewer assists on average, lower win percentage in general. There's a few kind of outliers, like these 2 dots seem like really low on the number of assists, but they have a fairly high win percentage. And then this is a really low dot. This is the lowest number of average assists and also pretty low win percentage. So it's, worth kind of investigating what happened there. Maybe you want to investigate like some of these dots, right? Some of these dots on the edges, like what's going on there, right? This kind of fits the general trend, so maybe that's okay. And perhaps if you remove these dots out here, maybe the correlation goes away. I'm not sure, okay? So these are certain questions, and you might want to say like, okay, what if I get rid of the teams with over 26 assists? Okay, there's 1, 2, 3, 4, 5, 6 teams. I think we would still see some kind of correlation, maybe certainly less. But anyway, I just thought, okay, well, let's just take a look at these 3 dots, the teams with the 3 lowest assists. And it's the 2015-2016 Lakers, and then the 2015-2016 Toronto Raptors, 2016-2017 Toronto Raptors. Okay, and so one thing about the 2015-2016 Lakers, that was like Kobe Bryant's final season that he was playing, and it was kind of like a farewell tour. A lot of people came, whatever game, and I think they just wanted to see Kobe play, right? And so, I love Kobe, but he wasn't known for sharing the ball very much, right? I don't want to get in trouble for saying anything like that, but so yeah, not a ton of assists. Also, just as far as like the Lakers, winning and stuff like that, they didn't win very much that season either. But that was okay, right? The Toronto Raptors, somehow they had high win percentages, and they just didn't have a ton of ton of assists. I guess a lot of the other players didn't didn't have a lot of assists, but they, I guess their bench was, or just their non-guard players were good at scoring points without necessarily having assists. But there wasn't anything too unusual there. I did not do a separate analysis where I removed teams with 26 or higher, like just these 5 points out here that seem to really influence the trend. But I think that's okay. Here, before I forget, let me give you your last two view quiz answers, which are the letters E and C. E as in elephant and C as in cat. E as in elephant, C as in cat are your two last two view quiz answers ever for the year. Okay, E and C. All right. Sorry. So here I've added a trend line. I did geom smooth, method equals LM, so I get a straight line, and this is kind of the plot that we see. And then, I gotta fix something here. But all right, so let me just fix one of these things. You could check the kind of summary on the linear model that I fit. So I did linear model, predict win percentage based on average assists, and we see the slope here is 3.13, 3.135. So just basically, if a team has about one more assist per game, we expect their win percentage to go up by about 3 percentage points, and it has a very significant p-value. P-value is 1 times 10 to the negative 6, so like 1 in a million type of thing. So this kind of correlation is not going to happen by random chance. The correlation value itself. That was the issue. Okay, I forgot to hit return, and then let me just do height equals 75%. So you can ask, what's the correlation between these variables? Hang on. So it's running. What's the correlation between these variables? The correlation itself is not super strong, but there is correlation there. Okay, so the correlation is about 0.426. The p-value is again 1.15. So I asked what's the correlation, and I asked to do a correlation test to see if it's significant, statistically significant, or could it be the result of randomness. So the correlation is around 0.426. The significant, it is significant, around, again, the p-value being 1 in a million, saying like, is it possible that there's no correlation between assists and win percentage? It's possible. If there really is no correlation between assists and win percentage, what's the probability that you would see a bunch of points where the correlation is 0.426? That kind of randomness happens only 1 in a million. So rather than concluding that there's no correlation between assists and win percentage, we're going to come to the conclusion that there is correlation between assists and win percentage, and that's why we're seeing a correlation of 0.42. Okay. That said, your R squared value is only 0.18. Okay, so only around 18% of the variation in win percentage is explained by assists, meaning, yes, more assists is associated with more wins, but not very, very strongly so. Okay, our squared value is only around 18%. So not a very strong relationship between assists and win percentage. Okay, and this is just one example kind of variable. But I really wanted to kind of highlight the importance of knowing what you're expecting your output to look like, and double checking your output as you go along to kind of make sure that it is aligning. And if it's not aligning, then go back and ask yourself, why is it not aligning? All right, and I would say, I kind of picked on this one group and their project, but it was not an uncommon problem to see in past group projects, that there were, you know, and maybe not necessarily the whole thing, but just like there were certain aspects where, you know, they messed up something in the summarize or messed up something in the deployer operations, and you know, I asked, you know, what would you have expected the thing to look like, and you know, that's not what it looked like. So okay, so anyway, just kind of I guess a little tip, little warning, just to encourage you to, you know, work carefully and work well. I have a favor to ask of you, and that is to fill out your course evaluation. I hope you feel like you learned something in this class. I hope you feel like you know, as far as data analysis goes, you know, a lot of it, I'm hoping this final project is a true learning experience, right? There's a lot of kind of things that, you know, you encounter when you're working with real data, you know, like some messy problems here and there. And so I'm hoping you can work through it and solve it. And so anyway, I hope you learned something in the class. I hope you enjoyed the class. And I want to ask you the favor to complete a course evaluation. And yeah, good luck. Have a happy Thanksgiving. I won't see you. Well, on Wednesday, I'll only see if you come to office hours, but feel free to stop on by. It's online only. And if not, if I don't see you, have a happy Thanksgiving. Good luck as you work on your final projects. And yeah, I will see you for your final presentations. All right. And that's it. Thank you very much.